Hello friends, welcome to this fourth video on power spectral density. We have been solving problems under power spectral density where the input function can be of different types, constant, algebraic, exponential and so on. So given power spectral density, how to find autocorrelation function, or given an autocorrelation function, how to find a power spectral density is the two different types of problem we have seen. So now this video will cover an algebraic input and how to solve or handle an algebraic input function. Come on, let's move on to the video. The problem is if Rxx of tau is going to be 1 minus mod tau in mod tau less than or equal to 1 and 0 elsewhere, find the power spectral density of the process. We have been given Rxx of tau, the requirement is power spectral density. Power spectral density Sxx of omega is the Fourier of Rxx of tau. So we will rewrite the formula for Fourier, which is integral from minus infinity to infinity. The input function is taken as such. If it is going to be positive Fourier, then the exponential function as a minus sign e power minus I omega tau. Tau is going to be the variable over here, so you integrate it with respect to d tau. Now step number 1, we will look into the modulus of the limit. The limit is going to be modulus less than or equal to 1. Modulus is a quantity that varies between a positive and negative. So the positive value is going to be plus 1 and the negative value is going to be minus 1. So I have my tau to vary between minus 1 and plus 1. So this is my first step. In my second step, let me go and apply all these quantities in the formula. So my Sxx of omega will be equal to integral, where the limit integration now exists between only minus 1 to plus 1, and in the apart from that, the other regions the value taken is going to be 0. So we give the input in the range as the one specified in the question, 1 minus modulus of tau e power minus I omega tau into d tau. So this is going to be my step number 2. Now in my step number 3, we will have to recollect the formula or the hint which we have seen. If the input is going to be algebraic, the exponential form is better expressed as a trigonometric function. So this will ease our evaluation. So what do we do is integral from minus 1 to plus 1, 1 minus modulus of tau, this e power minus I omega tau. I rewrite this as cos omega tau. Since it is minus sign over here, I put a minus sign over here, I sine omega tau, and now with respect to d tau. So this is going to be my step number 3. Now let me break this complex number into two parts so that in my next step I have this as integral from minus 1 to plus 1. You have 1 minus modulus of tau cos omega tau d tau minus I is a constant, so that can be taken outside. Integral from minus 1 to plus 1, 1 minus modulus of tau sine omega tau d tau. So this is how I split my last term, 1 into cos, and so the first term into cos and next the second term into sine. So if we split it as two terms, this becomes 1 minus mod tau cos omega tau and minus 1 to 1, 1 minus mod tau sine omega tau. Now this is as such, it seems like a big problem, but we will make it as easy as possible now. Like, see, whenever we have a modulus, what is the nature of modulus? When I give a negative value to it, say suppose I give minus 3 to it, what will be the output? The output will be 3. And when I give positive 3, what will be the output? It will be 3. So the modulus is going to be called as an even function, where you have f of minus x to be the same as my f of x. So modulus of tau is going to be an even function. And now similarly cos omega tau. Now when I replace this, tau is going to be my variable. This cos omega of minus tau, what do I know? That cos of minus theta is the same as cos theta. So cos omega of minus tau is the same as cos of omega tau. So now again I can see that my f of minus theta is the same as f of theta. So cos omega tau is also an even function. So this is going to be the second stage. Next, let me move to sine omega tau. What do we know about sine of minus theta? It is going to be minus sine theta. When f of minus x is equal to minus f of x, what do we call this as? We call this as an odd function. So what we have, sine omega tau, if tau is replaced with minus tau, what will happen if I replace tau with minus tau? I replace and then I get the answer as minus sine omega tau. So if tau is replaced with minus tau, then the value becomes minus I sine omega tau. So sine omega tau is going to be an odd function. Now why we are discussing about this odd function, even function and other things? We have a property of definite integral that states that integral from minus a to a, that is the range being symmetric. Symmetric meaning from the center point, this side is also the same and this side is also the same, like it is going to be the mirror image of one another. Like our normal distribution curve, whatever or how much ever we have on this side, the same thing is available on this other side also. So from the center line, if both the quantities are going to be the same, you call it as a symmetry. And the range minus a, this becomes minus a and this becomes plus a. From 0 to a, how much ever is present, if 0 to minus a the same thing is present, you call it as symmetry. So whenever I have the integral limits to be the same, with one varying in minus quantity and the other one varying for plus quantity, then you call it to be symmetric interval. The symmetric interval, the function f of x dx, if you are giving it as an input for an even function, what happens is the integral becomes twice integral from 0 to a f of x dx. So by symmetry, it is just sufficient that you evaluate one portion of it and then what you do, you multiply it by 2. So when this becomes a even function, for an even function, the minus a to a becomes 2 times from 0 to a. So 2 times from 0 to a f of x dx. And the beauty now is, when the function is going to be an odd function, what will happen? The function, this being positive and this being negative, will cancel off each other and the value of the integral will turn out to be equal to 0 for an odd function. So this property will help us simplify this problem to a greater extent. So we will see how this is going to work. Okay, so now what we have over here is integral from minus 1 to 1 minus modulus of tau cos omega tau d tau minus I times integral from minus 1 to 1 minus modulus of tau sine omega tau d tau. So I know that this modulus being an even function and this cos is going to be an even function, when I multiply even into even, this both of them is going to give me an even function. And for an even function in the interval from minus a to a, what will happen? This quantity will become twice integral from 0 to a 1 minus modulus of tau cos omega tau d tau. So this is about my first condition. Now moving on to the second part. What you have over here, modulus is going to be an even function. And what we know about sine, sine is going to be an odd function. When you multiply an even and with odd, what you get is going to be an odd function. And what we know about the property of an odd function will become 0 for the symmetric interval. So this entire second half, what will happen to it? This will now vanish to 0. So we just have 1/2 of the portion for our estimation. This is the primary motion. Why we are splitting this exponential function as cos and sine in a symmetric range. So whenever you have a cos and sine in symmetric range, we can talk about a symmetry of an even function and odd function. So the problem can be easily resolved over here now. Now getting back to the part which exists now. What happens over here? This becomes twice integral from 0 to 1 minus modulus of tau cos omega tau d tau. Now one more point or hint to remember. What we know is 1 minus modulus of tau. What is the nature of modulus? Modulus behaves in two different ways. between minus 1 to 0 it behaves as a negative value, and from 0 to 1 it behaves as a positive value. So 0 to 1 is now going to be our interval. Between 0 to 1, how does it behave? It behaves as a positive value. So what will happen? This modulus can be removed. I know that this behaves as a positive value, so this will behave as tau. So I have 1 minus modulus of tau cos omega tau d tau. So twice integral from 0 to 1, 1 minus modulus of tau cos omega tau d tau is going to be the final quantity which we are going to estimate it for. Now this is going to be an algebraic function where this part is going to be treated as your u and this part is going to be treated as your dv. So I am going to apply now the Bernoulli's formula where you differentiate your u continuously. 1 minus tau is going to be our u. What will be our u dash? U dash on differentiation gives us minus 1 and u double dash on differentiation makes it as 0. What is going to be our dv? Our dv is going to be equal to cos omega tau. What will be our v? It is going to be integral of cos. So integral cos is going to give us sine omega tau. This is going to be with respect to tau we are integrating, so the constant is omega, so you will have divided by omega over here. This is going to be my first derivative, integral v1. What will be v2? V2 will be sine on integration will give me minus cos omega tau divided by omega square, and v3 will be minus sine omega tau divided by omega cube and so on. So what you will have to do, you will have to club the data. So when I am going to club the data, what happens? This will stop with the third derivative. Only two derivatives will exist. This is one way of doing the problem. The best way to handle it is using a Bernoulli's formula. So in the Bernoulli's formula, what do we do is we start with 1 minus tau, which is going to be our u part. And now what happens to our v part? This dv part I am going to integrate, because you know that integral u dv is u v dash minus integral v into u dash. Okay, so you first take this u and v1. So what we'll have to do with this dv? We will have to integrate this dv. So on integration, this will give me sine omega tau divided by omega. The second term will automatically be negative because I know the formula contains alternatively positive and negative values. So what will happen? I will have to differentiate my u now. On differentiation, 1 minus tau will give me minus 1. What will I have to do with dv? dv has to be integrated. So when I integrate this sign, what will I have? I will have minus cos omega tau divided by, already there is an omega, one more omega will come, so omega square. Third term will be positive. What will happen to this minus 1? Minus 1 has to be differentiated. Minus 1 on differentiation will become 0. So the process ends over here. So what we have is going to be apply the limit between 0 to 1. Again I say the problem may look a little big, but it is very easy. Now you see most of the terms will vanish. How? Let us see the magic. What is going to be the variable which we are going to substitute for? We are going to substitute for tau. When I substitute tau to be equal to 1, 1 minus 1, what will happen? It will become 0. Now in the lower limit, when I substitute tau to be equal to 0, what do you know about sine 0? Sine 0 is 0. So 1 minus 1, upper limit will vanish, and your sine 0 is 0. So the lower limit vanish. So what will happen to this term? This entirely will become equal to 0. So I just have one term left out for me for substitution. So let me substitute this term. 2 times of 1, 2, 3. So that makes it as negative sign. Give your value of tau to be equal to 1 cos omega divided by omega square. So this is my upper limit minus lower limit. 1, 2, 3, and there is one more. So this will become plus. Now tau takes the lower limit, which is going to be 0. Cos 0. Cos 0. What do you know about cos 0? Cos 0 is going to be equal to 1. So I substitute the value of cos 0 as 1. So it becomes 1 divided by omega square. So hence I have 2 times of 1 minus cos omega divided by omega square. So this can be still further made into an simple and comfortable format by substituting 1 minus cos theta. What is going to be 1 minus cos theta? It is 2 sine square theta by 2. We know this trigonometric equivalent, so I can replace this 1 minus cos theta as 2 sine square theta is omega for me. So this now makes the final answer as 4 sine square omega by 2, and the constant over here is omega square. Keep in mind, at no point you are able to cancel this omega with this omega, because this omega is going to be an angle and this omega is going to be constant. So an angle can and omega and constant cannot be cancelled off, so leave it as such. This is going to be our final answer. So keep in mind what happens, the points to be remembered over here. Whenever first consider the interval split from minus to positive, then if the function is algebraic, rewrite the term as cos and sine, and we know that cos and sine can be treated as an odd and even function. If it is even, then for the symmetric range it becomes twice the value. For an odd function it becomes 0. So all the odd functions vanish, only even function exists, and modulus in an even range, what will happen? It will become positive in nature, and then finally you can apply the Bernoulli formula, and then we see that majority of the terms, when you apply either the upper limit or in the lower limit with sine 0, vanishes, and so finally trigonometric equivalence can be used to make the formula a simple and a more pleasing one, and so we have this final answer. Thank you.